Okay, back again, my friends. We're here with a Codewars exercise called Playing with Digits, done in Python. This is a familiar refrain. Yep. Python Code Wars. Let's get it. Some numbers have funny properties. For example, you have 89, and you break apart the digits, and then 8 to the first, 9 to the second, you add them together, and they're equal to 89 times 1. So 8 to the 1 plus 9 to the 9 squared actually is 89. Interesting property, I guess. And then you see 695, digits split apart, and then we have consecutive powers, and they're added together, 1390. It happens to equal the original number times 2. So there's kind of a thing where there's some number that you can multiply by the original number that will equal that number's digits raised to consecutive powers. That is the idea here. Looking at the 46288, and we have the digits split apart. Then we have consecutive powers here, and it equals this number. And lo and behold, it equals the original number times some number. So what this is getting you ready for is the idea that you can take a number, split its digits, and have its digits raised to consecutive powers, add the results together, and that can equal that original number multiplied by some number. Given two positive numbers n and p, we want to find a positive integer k if it exists, such that the sum of the digits of n raised to consecutive powers starting from p is equal to k times n. Getting mathematical on y'all. Yeah. So talking about the consecutive powers starting from p, you in this exercise, I'm going to get two integers as input. Integer n is going to be the original number, like one of these. P is going to be the starting power. Like in this first one, P is 1. That's the starting power. In this one, P is 2. And in this one that's kind of highlighted, P is 3. P is going to be your starting power. In other words, writing the consecutive digits of n, such as blah, 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 there's an integer k such that, a little kind of formula here, you raise it to the consecutive powers, the digits split, and my task here is going to be defined as the k that, or if it exists, that when you raise these digits to the consecutive powers, add them together, there is some mystery number, perhaps, that you can multiply by your original n and achieve the result of the multiplication of the digits with consecutive powers. It's a hell of a mouthful, right? There may not be a k, and if there is not a k, you're going to return -1. So a lot going on in this one, my folks, but we got it, and we'll persevere. Let's drop into the code, shall we? Let's get this. Knock this mother out. So the idea, or the beginning, is you need to split up the digits. You're going to have a possibly multi-digit number, so you need to split the digits so that they are you can access them individually. There is a mathematical way to do this, and you may have seen it in other videos that I've done. Not going to do it here. I'm going to do the more expedient way, which is going to be to take my multi-digit integer and turn it into a string so I can access each digit via character of the string and manipulate it that way. It is a lower code way to do it, kind of like the easy way. So I'm going to take n, which is our original number, and actually n is going to be on the other side. I'm going to take in and convert it to a string so I can loop through it and get each individual digit very easily. And I need to create a total of the additions of each digit raised to consecutive powers. I needed to store that somewhere, so I need to put it in a variable. I'm going to make that variable equal to 0. Yes, yes. This is my announcer voice. And I'm going to use a while loop to loop through the characters that are really digits. So I'm going to use an iteration variable because we got an index in, so I got to do that. And then I'll do while I is less than the length of my string, which is going to be the digits. I am going to do the addition of the digits raised to a power. I got to do an integer conversion on the string, and I got to index into the string to get the digit. Whoops. Yeah, that NSTR index I, that is me indexing into the string to get one digit. I'm going to raise that one digit to the power of P. Haven't mentioned P yet, but P is the power. So it's going to be set to something to begin, and it's going to increase for each iteration. Just like you see over here, where you have the P begins at 3, then it increases to 4, 5, 6, and so on. It's going to start at something increase, but for each iteration, it's going to be used to raise the digits to a power. So I'm doing that. And then I get in here and I'm gonna increase P and I'm gonna increase I to move the train along. Once the while loop is done, I've got my total of the additions. I've got my result number. Now I gotta find out if there is a k, if there is a number that when multiplied by the original n is equal to this total that I have. So I'm going to see if my total that I have is, see if it is divisible by n by using modulo, because that's going to check divisibility, because if a k exists, then k times n equals total. If n is not divisible, or if total is not divisible by n, then there is no k. If it is divisible by n, then there is a k, and I'm going to return it. And I'm going to return it like this. I'm going to return it by total divided by n, because if n times k equals total, then total divided by n equals k, and I will return k. So line 11, it is really a formula to get k using some property of math that I don't remember. Like, I don't remember the names of the properties of multiplication and division and such, where you take the multiplication, you turn it around to division, and yeah, whatever. I'm not a mathematician. I'm a programmer. Probably should be better in math, but I will be maybe someday. Anyway, so that's going to return my k. There exists the possibility that there is no k. If total is not divisible by n, I hope I'm saying that right, it's there's no k, and I'm going to return -1. There we go, folks. I think that's it. Cut and print. Let's see what we got. That looks good. Alrighty. Correctamundo, correctashundo. Take that to the bank. Alright. Time to fire it up, homies. There is your solution to playing with the digits. There's a solution. This is my solution, actually. There's probably 1,000 damn solutions, but this is my solution to playing with the digits. Codewars, Python, let's go, let's get it. And we out. Or at least I'm out. You can stay, but I'm out here. See ya.